Step 5.2 distance-based methods. The first distance-based method we want to apply for constructing clusters is hierarchical clustering, and we'll illustrate hierarchical clustering using the risk dataset, which is available in package MSA. So we're loading that dataset using data, and with dim we get the information that this contains 563 rows and 6 columns, which means we have information from 563 respondents on 6 variables, and the variables were indication of how often they undertake certain risks. This was scored on values from 1 to 5, and we can calculate the average risk taken by all of the respondents. We see that the average risk is about 2 for any. There are only slight differences on average, but this doesn't mean that there might not be different groups of distinctly different risk behavior. Just aggregated overall respondents, it's about 2 for all of them. To now group respondents, we use hierarchical clustering. Hierarchical clustering is implemented in R in the function hclust, and the first argument of hclust is a distance matrix. So first what we need to do is we need to take our dataset risk and we need to calculate a distance matrix between our respondents, and here we use the distance measure Manhattan, so we specify method equals Manhattan, and this calculates now a 563 times 563 distance matrix containing any distances between two respondents. And for applying hierarchical clustering, what we need not only know what's the distance between two observations, but we also need to know how we calculate distances between groups of observations. And this is defined by the linkage method, and the linkage method is specified using argument method for hclust, and here we want to use complete linkage. So we apply this, and hclust returns an object of hclust. So printing that object gives us the information on how was this object created and which cluster method was used, so which linkage method, what's the distance used, and how many objects were contained. And this contains all the information of the sequence of partitioning which we have created using hierarchical clustering. And normally the easiest way is to see how does this look like. We can use the plot function. Plot function applied to that object returned by hclust creates a dendrogram. So plot again is a generic function which does different things in R depending on what's the first object here. Because this is an object returned by hclust, the default plot for this is a dendrogram. We don't want to have a title for our dendrogram, and we don't want to include labels for the individual observations, because for 563, and they'll be numbers 1 to 563 anyway, so they can contain information in this context, but there could be other applications where you might want to add here the names of the individuals, because here at the bottom we have the individual observations, and then they are merged at different time points. So the two objects which have the closest distance are merged first, and the distance at which they are merged is indicated here on the y-axis. So we see here we have 563 observations, and over time, if we increase the distance we're willing to allow, we merge them step by step. And we see here, for example, the last merge happens, and to merge the two last groups, this takes a big value. So the distance between the last two groups is nearly 25. Long time between one merge and the other merge is often an indication that this group is quite far apart from this group. But we could think of, if we cut the dendrogram now at the height of 20, we would get two groups. This can be done in R, the cutting, using the function cut tree. So the dendrogram, that's the tree, and we want to cut the dendrogram at the height of 20, and this will give us a two-group solution where one group contains 511 respondents and the other group contains 52 respondents. Alternatively, we could also cut the tree in a way where we want to specify the number of groups we want to have. So we can say we want to have 6 groups, and then the cut tree function will select the suitable height. And then we see what would be the result for these 6 groups if we cut the dendrogram at a height to obtain 6 groups. And if we want to compare those 6 groups, what we could do is we can use the function aggregate, where we use the risk information, and we split sort of the dataset risk by the cluster assignments, and we calculate the call means for each of the groups. And then we can compare them. Function aggregate adds at the first column the names of the cluster 1, 2, 3, 4, 5, 6. Here we don't want to plot that, so we are removing the first column and we're rounding the data to 1 digit. So this is what the aggregate function does. In the rows we have the clusters, and this allows us now to identify what are the profiles of our different clusters. If we don't want to look at the table, we can use package flexclust and the bar chart function there, where in the bar chart function we put in our dendrogram, the data set itself, and we tell how many clusters do we want to have. So we're using this to split the data set into 6 clusters, and then for each of the clusters we want to show what does their profile look like.